So, yeah, thank you. Hello, everyone. This is Surhud from IUCAA, and I had given this talk for hunting up for Planet 9 in our solar system. I think it was in the November of 2018 in the Pulastya Festival. And this particular talk, it was very special, of course, for me because I typically don't work in the solar system. But it's a new thing, right? So astronomers often get bored doing the same things, and then they want to enter into new areas. And it has been a pleasure to work in this particular area. So the talk is interesting. The research topic is interesting, just because I can explain it even to my 7-year-old child. So what we are trying to do is trying to find a new planet in our own solar want system. To enter in. Yeah. Hello, Samir?
Yeah, please go.
Okay, sorry. Yeah, so we were trying to find this ninth planet in the solar system, right? So there are multiple questions that come about, right, when you look at this topic, and that is about the discovery of planets in our own solar system. So how do people go about finding what planets are, and how to find new ones? So, of course, mankind had known about the 5 bright planets which are present in the solar system, namely Mercury, Venus, Earth, of course, is known, but it's our own planet. But the planets which are seen in the sky, so then it comes Mars, Jupiter, and Saturn. These were things which were known because you can see them by your naked eye. Many civilizations have known about this. But then the modern planets, Uranus, Neptune, these are the planets which were not known to the civilizations, but they were possible only once the telescope was discovered, right? And so within this talk, I tried to give an idea of how Uranus and Neptune, and at that time, what was considered a planet, Pluto, was also discovered. In fact, during this talk, I also gave a summary of how teeny tiny Pluto is and why we don't really consider Pluto to be a planet right now. Right? But one of the interesting parts of this talk was to try and understand what is it that actually makes a planet, right? And so to tell you the status of Pluto, but then also to tell you how these planets get discovered through difference imaging. So you image the same part of the sky many, many times and try to look for things which move, right? Just because planets are going around the sun, right? Then they move with respect to the fixed background of stars. So that particular method is something that has not changed yet. If you want to discover anything new in our own solar system. So I tried to explain that particular method as well. And then I told you how we are going to search for this planet, which kind of telescope we are going to use. So it was the Subaru telescope. So at the end of, after that talk, I think I had to leave in a few weeks from then to go to Hawaii in order to look for this planet. Okay. And so one of the pictures that you're seeing on the screen, Samir, is the screen visible? Yeah. So once I went to Hawaii, we had some nights which were allocated to us, right? And oftentimes it used to be half nights, which means that we had to go there at around 12 o'clock in the night or midnight, and then take pictures. But that also meant that the earlier part of the night was free for me to do whatever I wanted to. And so I could go ahead and take beautiful pictures of the sky in Hawaii. So this site called Mauna Kea is where the Subaru telescope is located. It is one of the best sites for doing astronomy. And of course, that's why a best site for taking beautiful photographs of the sky as well. So what you're seeing in the background right now, yeah. Yeah, I have switched on the slide. Can you see it? Okay, I will stop sharing and start sharing again. Oh, I stop share not working. Let's see. Okay, for some reason, stop sharing is not working. Can you hear me, Samir? Okay, something went wrong. No problem. So we ended up taking lots and lots of beautiful photographs of the sky. And you can see the Milky Way and the Milky Way moving around and so on and so forth. As soon as we resolve this technical glitch, then I will try to reshare this. Is it working? Can you see my screen? No, I thought we tried it out before. This is strange. Yeah, no problem. We will see. We will try to get that sorted out as well. Okay. So yeah, so that was the talk. I wanted to give you an update. We did go to Hawaii, try to look for this Planet 9. And the update from the analysis, it takes a lot of effort in order to actually analyze this data. And we have been going through it for a number of years now, or almost 2 years now. And we did a preliminary analysis. And in that preliminary analysis, we are able to find many things which move, but nothing which is consistent with Planet 9 so far. Okay, and so of course, if you had found a planet, then you would be the first ones to know, because then we would have put out a notification regarding a new planet which was found. But so far, we have not been able to discover it. There are multiple reasons for it, and you could ask me about them, of course, in the question and answer session. And so that's where we are. Okay, so that's the update from my side, and I would be happy to take questions.
So thank you for the recap, and I think we have had several technical difficulties. Maybe so what I'll do is I'll just repeat my words about the second Saturday lecture series, and in that meanwhile we can try the doing slides.
I will try to reconnect again just to see
sure.
whether it's
Thank you.
Thanks.
Thanks. Okay. So, so welcome everyone again. As I was saying earlier, several difficulties today, but we are hosting the second Saturday interactions here live, and this is coming to you from IUCAA. Here we have Professor Surhud More today here with us, and he'll just be back in a moment with his slides. So this series has been going on for more than 2 decades, and it has attracted many students from various years, various generations in fact, and they have gone through this lecture series and have felt inspired by the presence of a practicing scientist, and they get to talk with them, they get to ask them questions. So this, we were missing this during this particular situation, and so we thought we'll take it live online and get you all together here to actually revisit our lectures from earlier. So we have lectures which are online on our YouTube channel, and we are always looking forward to you looking at them again and again, because there's always, when you revisit something, there's always something new to be discovered. So just like scientific discovery, and probably something which Professor Surhud also does. So we have Professor Surhud here, and he is going to, he has just recapped what he has talked about in the previous talk. Now he's back, and I think you can see his slides. So let's go on and keep listening to him for the rest of the interactive series. I will just remind you that this needs to be an interactive series. So what we'll do is we'll ask questions. The YouTube chat is there. You're watching this on YouTube. There's a chat box on the side. So please feel free to basically, just ask questions there, and we will pass them on to the speaker. So I can in the meanwhile, maybe Surhud, you could show us pictures that you
yeah, sorry about that. Even after many months into the pandemic, we always run into technical glitches once in a while, but that's okay. So what you're seeing are beautiful pictures taken from IUCAA of the sky. There's a visitor center down where we stay during our observations. And then I just set up a tripod there, took a DSLR camera, and then shot these beautiful pictures. You can see the Milky Way just turning around. This was, I think, shot for half an hour or so. And then I combined all the pictures to make a beautiful movie. You can see the skies turning around the North Star. So I have multiple pictures like this. I can even give you a quiz because I took a few pictures which are quite interesting and that you might enjoy. And so I will give you a quiz at the end where I will ask you to guess what is there. Okay, in the picture.
Okay, that will be exciting. Okay,
so let's start with the questions, and then
yes, definitely. So we have a few enthusiastic students asking questions. If you could begin with the previous ninth planet. So it's right now called called a dwarf planet, Pluto.
Yeah.
So somebody wants to know why is that so?
Right. Yeah, that's a good question. So I had gone through part of this in my slides. So let me try to show you where Pluto is. Right. So if you look at Pluto, so I think in the talk I had shown these discovery images of Pluto. Okay, where I had shown these images, and I will show you two images, one after the other. Okay. And I had basically asked you to guess where is Pluto in this. Okay. So should I start from the beginning? Or, okay, no problem. Yeah.
Sorry for the interruption. Just please continue.
Right. So one of the questions that was asked was, why is Pluto not considered a planet, and why is it a dwarf planet right now? and masses of planets that we knew at that time, and the laws of gravity as given by Newton. And so it was found that the orbit of Uranus showed some anomalies, so some deviations from what you would expect. And that is how a new planet was found, or a new object was found. This was Pluto, and I had shown in the during the talk a couple of images, the discovery images of Pluto. So I had gone back and forth, and I had asked people if they could see Pluto moving in the two images. So just keep an eye on the object here, and between the two images, you will see it move. Okay, so from here to here, right? So that is how Pluto was discovered. So people thought Pluto is the one which is causing the perturbations in the orbits of Uranus and Neptune. Okay? And so they thought it must be really, really massive. But then why is it so tiny, right? So they invented lots and lots of things to make Pluto extremely tiny, but very, very massive. Okay. It was only later that it was discovered that actually Pluto is not that massive, because there is a moon which is going around Pluto. So that helps us to measure the mass of Pluto. And it was discovered that Pluto is extremely tiny. It was also discovered that the orbital anomalies that were expected for Uranus and Neptune, it had to do with a wrong mass being attributed to Saturn. Okay, so once Cassini flew to Saturn, it could go around Saturn and then measure the mass of Saturn very, very precisely. So there were problems with the measurements at that time, so with the observations at that time. And so that's why people thought that Pluto is really massive, and so that it should be a planet. But once it was known that Pluto is not that massive, many years, many decades have gone by. Discovered many, many different kinds of objects which look the same as Pluto. Okay? And when you look at them, you can ask, okay, if Pluto is a planet, why are these other objects not a planet? Okay? And so if you consider Pluto to be a planet, there will be a big crowd of many, many other objects in the solar system, which you would have to call planets. Okay? So that's one of the scientific reasons why people have stopped calling Pluto a planet. And of course, it was codified by the IUCAA by saying what exactly you should call a planet. So Pluto is, of course, part of these things called trans-Neptunian objects, which go around the sun, and it has not cleared the orbit of many of these objects, right? So, for example, if you look at Jupiter, and Jupiter is moving around the sun, then there are no small planetesimals which are going around the sun in the same orbit, right? So it has cleared out its orbit just because of its mass. But if you look at Pluto, then there are many, many such things which are in similar orbits and which go around. Okay, so let me just give you Pluto in context. So, for example, these are the planets. If you look at these planets, right? So there's the Sun. All you see is Jupiter, Saturn, Uranus, and Neptune. But then there are the terrestrial planets. And look at Pluto, right? Pluto is right down here, extremely tiny. And then there is another planet, another thing which was found, which is actually even more massive than Pluto as well. Right? So there are a number of such objects in the solar system, and that's why Pluto had to be removed. It becomes extremely clear when you look at the orbit of Pluto. So this is Pluto. But then these are different planetesimals which have been found, which are in similar kind of orbits as Pluto. Okay. So once you start looking at these kind of images, and these are really found objects which have their orbits beyond Neptune and which show very, very similar characteristic of orbits like Pluto. Okay. So once you see them, then it's like, okay, Pluto is just one of these thousands and hundreds of thousands of bodies which are going around the sun. There's nothing special about it. Okay. I hope that answers the question.
Sure, that was an extensive and very well illustrated answer. Thanks for that. We have some basic questions also there, which one of them is in the solar system, do all objects move continuously? So I think that can lead to the next question.
Yeah, sure. Yes, of course. So in the solar system, everything has to move continuously. Otherwise, it won't be able to go round and round the sun. So, for example, if you just have a planet which would be stationary, then because of the gravitational force of the sun, it will just get attracted to it. Okay, so it will just go and directly bump into the sun or collide with the sun if it was not moving. The reason why a planet goes round and round and it is in a stable orbit around the sun is because it is moving in a tangential direction. Okay, so if the sun is here, then it has to go in this direction so that it can keep on moving around, even though there is a gravitational force which is attracting it to the sun. Okay. So people who are more technically minded would identify it as a centripetal force, the gravitational force acting like a centripetal force. Or if you go to the frame of the planet, then it's the centrifugal force, which is keeping the planet uh, from going inside and or colliding with the sun, right, or getting attracted to the sun. So that's the reason why it keeps on going round and round. Of course, the speeds, you can ask, okay, what is the speed of these planets, right, when they're going around the sun? So let's just start with the Earth, right? Earth is at such a distance, given the mass of the sun, it has to go around the sun at around 30 kilometers per second. Okay, so it's not per hour. 30 kilometers per hour would be extremely slow, right? But it's 30 kilometers per second. You can just think about how mind-boggling that number is, right? When compared to any speeds that you see or experience in the on the Earth, and yet it is very hard to feel that motion of the Earth going around the sun, right? It feels that the sun is moving extremely slowly, or if you look at the stars behind the sun, right? And the reason for it is that the Earth is really, really far away from the sun as well, right? So even if it is moving at 30 kilometers per second around the sun, it takes 365 and a quarter of a day in order to complete one revolution around the sun. So you can imagine how big that distance is. Okay. So yeah, to give a short answer, yes, everything just has to move around the sun. Otherwise, it will have to just collide with the sun or get attracted to the sun.
Yes, of course. So I think this could lead to the answer of the next question, which is, what is the factor which assures us that there is there might be a planet nine? So why are we?
Oh, okay, great,
Why are we
great
finding?
question. Right, yeah, yeah. So what has happened is people have found these kind of objects which look like Pluto, right? So they have found quite a bit of these orbits. Most of them, they just hug the orbit of Neptune, so they are very close to Neptune, and they go around the sun. So these are shown here by these kind of bluish lines that you see. But then, in addition to these objects, there were a couple of odd orbits that were discovered in about 2003 and then 2012 again. So, initially in 2003, an object called Sedna was discovered. It has this kind of an orbit. It is very, very highly elliptical, right? So it is very different from these other trans-Neptunian objects that Pluto is part of. So it was pretty elliptical. The size of this orbit was also pretty humongous compared to the other orbits. And then initially, when only one is found, people think that, okay, maybe it's an oddball. Uh, uh, you don't have to worry too much about it. But then in 2012, another one was found. It was called Biden because Joe Biden was the vice president in 2012, so it was given his name. It's called VP113. That's the official astronomical name. And you see that again, it has this kind of elliptical orbit, and people are again confused. But then this actually the um, started people to explore this kind of outskirts of the solar system much more. Right? And when they went ahead and observed these orbits, they found that these two are not the only objects. There is a family of objects which have elliptical orbits, which look like this. Okay, but then there is something odd about these orbits. Right? And one of the things which is odd about these orbits is that all of these orbits are towards one side of the sun, right? So if the sun is here, if everything was random, you would expect there to be orbits like this, like this, like this, so on and so forth, right? But instead, what you see is that all of these orbits somehow are being pulled towards one side. And then the question is, okay, what is causing this? So these are the oddities in the orbits of objects, which are in the outskirts of system, which led to the hypothesis that there might be a new planet in the solar system. Okay? So one of the things that people thought initially is, okay, so where could the new planet be, right? And of course, our initial intuition, and many scientists thought this as well, including my collaborators who first proposed Planet 9, was that the planet should be going around on the same side as these other orbits that you are seeing. Okay, so that's what they thought. And that's why everything is being pulled in one direction. And it must be some kind of an elliptical orbit. That's what they thought, right? But then they said, okay, let's not just go on hunches. Let's actually run computer simulations. So they ran big numerical simulations in order to figure out whether this really would happen, right? So if there was a planet which was going around the sun in an elliptical orbit like this, would it lead to some of these planetesimals which have elliptical orbits in the same direction as the planet itself, right? And so they ran these simulations, and what they saw is something else, right? So what they see is when you run, so these blue objects that you are seeing, these are planetesimals which were distributed all around the sun. And then they put planet 9, which is going in an elliptical orbit like this around the sun. Okay, and then they run this simulation. So in the simulation, what happens is they have the planet has gravity, and these planetesimals, the other planetesimals, they act or they have their orbit, which is determined by the gravity of the solar system objects. So the sun, as well as Jupiter, Uranus, Neptune, Saturn, everything else, right? And in addition to that, this new planet that we have put in. Okay, so they experience this gravity, and their orbits then undergo some changes just because of these gravitational forces. Okay? So this is something that you can simulate, and you run this simulation for many, many years, many, many millions of years. In fact, many, many billions of years, and then you try to see what happens. Okay, so what they noticed is something very funny that happens. Okay, so they noticed that all the orbits which are close to this planet, which are inside the orbit of this planet, they actually get dried out. Okay, so the planetesimals which go in these kind of orbits, they get removed. Okay, and the reason why they get removed is that they come very close to the planet, and then the gravity of the planet pulls it out of the original orbit that it had. And when it pulls it out, then it just gets flung away. Okay, so it doesn't remain in the same orbit as it was initially going. So then this introduces a kind of asymmetry where you see a lot of orbits on the other side of the planet and very few orbits on the side where the planet is orbiting the sun. Okay? And this is because of the gravitational interactions. In fact, you can ask, okay, so what is special about some of these orbits which survive, right? And the special thing about these orbits which survive is that they are resonant orbits, which mean that they go around the sun in some integral multiple of the time that the planet 9 takes to go around the sun. Okay? And so then they can hide from this planet, because when they come close to the sun, then planet 9 is very far away. And then when they go far away from the sun, then planet 9 comes here, but then it doesn't affect them because they are so far away from each other. Okay? So this is how they can hide these interactions and hide from getting like washed away or swept away by the gravity of planet. Okay? So these are the kind of interesting gravitational interactions which are happening, and interesting alignments that you see in the solar system, which alignment of the orbits, I should say, not just the planetesimals, but alignment of these transcontinental objects, which then allows you to speculate that there should be a planet. But of course, you can't stop on speculation. You want to actually find it, right? And so that's why we go ahead and try to find this particular planet by taking multiple pictures of the sky.
That's a great revelation, and that the gravitation that seems to be invisible or still shows its influence at such large distances on large bodies, and
Indeed.
we can find them without even seeing them. So the other question, I will actually club two of these together, is that could there be more than one planets outside Neptune? So it's like, should it only be planet 9? Could there be 10, 11, 12? And what about the
No.
could there be dwarf
There's no
planets?
reason.
Okay.
Right. There's no reason why it should just be one planet. In fact, you could explain the same kind of thing that is happening if you had two planets, right? Or if you had a ring of mass which is going around the sun in the same kind of orbit that we have predicted for planet now. But it needs to have the same mass, of course. Right? Unless you have the same mass, it doesn't produce the same kind of gravitational effects. So the reason why you speculate one planet is because of something called Occam's razor, which is you try to come up with the simplest explanation for the phenomena that you see. And typically the simplest explanation turns out to be closer to the truth. Okay? So that's why we speculated that it should be one planet and we try to hunt for this planet. Of course, nobody is precluding that there may be other planets even at a further distance away from what we are asking Planet 9 to be. So there could be many more planets out there. We don't know. But what is it that you would call a planet? Right? And that's where IU has come up with a definition. It has to be big enough. It turns out to be round. It has to go around the sun, not around any other body. And then it has to have cleared out its orbit. Right? So it has to do all these things. Unless it's massive enough, it cannot do all these things, right? So the question is, can we find something which is, say, something few times the mass of the Earth at these kind of radii? So far, we have evidence for maybe one. We're trying to find even that. It's a difficult task. But if there are things out there, we would like to find them, of course.
Amazing. All the best for that. And so one question is that you just said about dwarf planets. So what differentiates them? What is that specific thing which differentiates them from planets? And would it happen that the planet 9 that you find could be a dwarf planet?
Right. So planet 9 that we so the main differentiating thing currently between the dwarf planets and us, they could basically, if they are not clearing out their orbit, right? So clearing out the debris. So maybe you need to think about how planets form in the first place. Right? So when planets form, it's the early stage of the solar system. Even the sun is forming, right? And around the sun, there's a giant cloud of gas, and it is this disk of gas which is going around the sun, which then turns into the solar system, or which then turned into the solar system. Okay? And within this cloud of gas, there were inhomogeneities there, and this is an active field of research. Okay? How to form planets starting from a disk, a planetary disk around the star, and then basically there are some clumps which form, and people try to figure out how you can go from teeny tiny particles in this disk, how they can stick to each other either because of gravity or the solid state forces between them, and then how they could become bigger and bigger and bigger and bigger and bigger. Right? So at that time, in the initial stages, there are these big blobs that you form just because of gravity. Things get attracted to more and more massive objects, and then these blobs are going around these big disks which are around them, right? But then as soon as you form a big blob, it starts to attract all the material, and just like you saw the debris clearing up because of planet 9 in this simulation that I showed you, in a similar way, these planets start to clear out the debris. And so instead of seeing the giant disk of dust around the star, what you start to see are these small planets, right, which get coagulated. And some of them can be just made up of gas because most of the material in the disk is gas, and some of them could be terrestrial because there is dust as well, right? So like planets up to, say, Mars. So these kind of this is what basically distinguishes planets from non-planets, right? are you clearing out the debris which is left over from this planetary disk or not? Okay. Now, if we look at the planet 9 that we have postulated, which can create these kind of orbital alignments, then the mass of this planet needs to be of the order of 5 to 7 times the mass of the Earth. And if we have this kind of a mass at this distance, then it is expected to clear out all this kind of a debris. Okay. And so if we believe and find an object at the right distance and which has the right mass to explain this orbital element, then it cannot be a dwarf planet. It will have to be a planet.
Okay.
And so that's why we call it a planet 9 or a possible planet 9 and try to go and hunt for it. Of course, if we find something which turns out to be extremely tiny, then it will just be a dwarf planet, right? And in fact, we have found many such objects which have orbit just beyond Neptune. Because whenever we go and search for planet 9, at that time we have to take images, and we take one image and we take another image, and we see whether things have moved from one image to the other. Okay? Because we take one image today and one image on the next night or the next night, and so on and so forth. Right? And so if these things are moving, then you can see them moving on the images as well. Okay. And we have found many such objects which are moving, but they are extremely tiny. They don't have orbits which match the orbits of planet 9. And that's why we say that we have not yet discovered planet 9. I can actually show you one of these images. Let me try to find out if I can find images. Yeah, here you go. So what you are seeing here are images which I have taken on 3 different nights. So night 1, night 2, night 3. On night 1, we took 3 images. On night 2, 2 images, and night 3, 2 more images. Okay. And what we have done is, there's a RGB color channel, right? So all the images in night 1, we put it in the red channel. Okay. All the images in night 2, we put it in the green channel. All the images in night 3, we put it in the blue channel. And now we added all these images to make a color image. Okay? Now you know that if there are objects like galaxies in the sky, right, and there are objects like galaxies and stars in the sky, if you look at them on 3 different nights, they will have exactly the same positions and exactly the same amount of brightness to these objects. Okay? They don't change much. And so if you add up RGB with equal intensity, then it will look white, right? So that's what's happening. Most of the objects in this image are white, okay? And so these are objects which have not moved at all. But then there are some red dots and green dots and blue dots. And these objects are the objects which have actually moved. It is actually the same object. On night 1, when we took the first image, it was here. Then it went on the second image to this place, on the third image to this place, on the second night, first image to this place, second image on night 2 to this place, and on night 3, these 2 images. Right? So you get the idea of how you can discover these objects which move. And I'm showing you one of these objects which has moved, but it turned out to be more of a trans-Neptunian object in this particular case. Okay? So something which was just moving around. And not a planet 9. If we had planet 9, it would actually not move that much between the 3 nights. It will move maybe a few pixels around in this. So that's how we discover these new objects.
All right. So there have been several good questions and really good answers as well. I think we should go to the last question because time is almost over.
Sure.
For a while. So this is about life, and we are always interested in if there are aliens elsewhere, whether they are bacteria or intelligent beings is a different thing.
Yes.
So how probable is it that, I mean, could are planets more probable to host life than dwarf planets? And if you find planet 9, could it have life that far from the sun?
Yeah, so it's a very interesting question, of course. We don't know what is out there and where life can be found. Of course, life has its own ways as well to pop up, right? So even if the conditions are not exactly suitable to what we are used to for life, life may still pop up, right? And I think one of the best examples of this, I don't know if you've seen this research that came out only a few weeks ago about the presence of phosphine on Venus.
Right.
This phosphine is a chemical which is very hard to make through non-biological sources. And some of our colleague astronomers, they have found evidence for the presence of phosphine in the atmosphere of Venus. Now, Venus is extremely close to the sun, and it has a very, very toxic nature. The temperatures on the surface are very high as well. It has undergone this greenhouse effect, something that can unfortunately also happen on the Earth if we don't control carbon emissions. So something like this has happened on Venus, and yet still life may have found a way to be present there. Right? And so it's extremely hard to say where life may be present and where it may not be. Right? Of course, you still need like temperate amount, like the temperature needs to be appropriate. Water may exist, may not exist, who knows? And so all these kind of questions about what exactly uh, you can imagine where life can thrive. Nature is much more creative than we are, unfortunately, or maybe fortunately, right? Otherwise, we may not have been here, right? And so it's just that we need to keep looking, right? And so if you ask whether things could exist on Planet 9, it's less likely just because it's so far away. Most likely it would be an ice giant. But beneath the surfaces, if it has an active core or something, then you might expect possibilities, right, of life being present. But who knows? I think it's an extremely difficult question to answer right now, and I'm no expert on this particular field, and I won't even pretend to be. But yeah, I mean, I think these are the questions. These are the kind of questions which should inspire many of you in the audience to go ahead and study astronomy and try to find the answers to some of these questions by yourself. Become astronomers. Try to find out life. Maybe in our solar system, maybe in exoplanets which are found in other stellar systems. So please go ahead, become astronomers. I want you to do that. I would be very happy if you can find such signatures of life. And I think I should also advertise at this point that India is also part of a big project called the 30-meter class telescope, so 30-meter telescope, which would have instruments which can try to detect some of these signatures of life on exoplanets. So this is something which will come online when you will become researchers. So if you are in like 11th or 12th right now, it will take a few years for you to complete your graduation, do your PhD. But by the time you're doing your PhD, some of these telescopes will have just started to come online. The European Large Telescope, KMT, which India is part of, and so on and so forth. So you will have the tools available in order to do this. So please try to think about and dream about being astronomers and try to find and get into these exciting topics.
Sure. Thanks a lot for those words. Could you stop sharing the screen?
Yeah, sure. I actually wanted to give a question as well.
Oh, please. I'm sorry. Yes, please go ahead.
So let me just find out the picture that I wanted to show. Okay, so just a moment. Okay, so I'm going to stop sharing and restart my screen share, opening up exactly the photo that I want to share. Okay, so are you able to see a picture?
Yes.
Okay, so I told you that I have gone to Mauna Kea in December of 2018. Okay, and there was a funny thing in the sky which was happening in December of 2018, and I tried to capture it in this picture. Okay, so if you can look at this picture, I don't know how clear this picture is to you, so I'm going to zoom a little bit further. Sorry, just a moment. So let's zoom a little bit further. And you look at this picture and try to guess, is there something interesting that you can see in this particular picture? Please post your answer in the chat, and some of our volunteers will take a look and try to answer whether it's the right thing. Or you have guessed the right thing that I'm trying to ask you to look at. Okay?
In the meanwhile, maybe I can ask a quick question to you. So, which direction of the sky do you look for finding the new planets that you're hitting?
Oh,
So it's like-
yeah. So right. So it's interesting. So I did touch upon this subject in my talk as well.
Yes.
So it turns out that if Planet 9 is found, it would be in one of the most picturesque places in the sky. So we think that it should be very close to the. Okay, now I'm blanking out. That's weird. So near Orion. And then there's Perseus, right? So if you look at the constellations near Orion, Perseus, and Rohini, Rohini is called Aldebaran in English. Samir, you might know better than.
Rohini is Aldebaran, that's right.
Aldebaran, right? Okay, yeah, good. So it's around that kind of an area. Unfortunately, it's a very vast area, and so we have to use a big telescope in order to scan all of this area. In fact, because Aldebaran is so bright, we had to take care that we are not going too close to Aldebaran. Otherwise, it would burn out our images. Or in CCDs, it looks very good. Otherwise, so we have to face these kind of problems. And, that's roughly the area. It's one of the most picturesque areas.
Yes, definitely. And I'll ask everybody and I'll remind everybody that this month we have something called the Orionids meteor shower. And it should be there around the 20th of this month. So that's the area. I mean, of course, you won't be seeing the ninth planet there, right?
You won't be seeing it with your naked eye,
yes. But if you know, you could have a night out on your roof if you are lucky enough to have a terrace, safe terrace. So do try to watch these things. These are also part of our solar system, things which enter the Earth. Then there are things which are farther off, and that can come back to the quiz question here from Dr. Surhud. Any ideas? I don't see any correct answers yet, though I can see a galaxy is one of the common answers.
Okay.
Sanjay says it's a pin. It could be pinwheel galaxy. Star, star.
There are many stars, but stars
yes,
are very
there are
common.
many stars.
Galaxies are harder to see in these DSLR pictures, but it's not a galaxy, it's not a star, it's something else. It was something which came around in the time of Christmas 2018. So that's a big hint, actually.
And it's not a planet, it's not Planet 9.
It's not a planet, it's not a planet 9.
But maybe give
No
a hint.
I mean,
distance.
Of course, people can continue speculating on the chat.
Sure.
Yeah. It was wonderful interacting with all of you. Samir is.
Please give the answer, I think.
Huh?
I think please give the answer.
Okay. So in the December of 2018, there was a comet which came by. It was maybe a naked eye comet, or maybe you needed some binoculars in order to see that. And this is what we have pictured. So do you see this kind of greenish blob here? That is the comet.
Okay.
And let me zoom in further so that it becomes clearer. Okay, so this was the comet that I could spot as well. So I took the DSLR camera and I looked in the general direction of where the comet should be, and then just shot the picture. It was a short exposure, I think 10-15 seconds or so, and then you could easily see it on the picture. That's what it is.
Okay, so it turned out to be something closer by than galaxies. But it's a fuzzy object and it's a planet. It's a comet, not a planet.
It's a comet, exactly.
Lovely. All right. So thank you, Surhud, for this wonderful interaction, and also showing some really personal pictures that you've taken of the sky. You love the sky, and I think you've also inspired others to have a better relation with the sky, if not just aiming to becoming an astronomer, they should at least continue looking at the sky for all the beauty and the extra information that we get about it. So, so lovely to have you here, and lovely to have all the viewers who are watching us live. And of course, our interaction will be recorded and kept on our YouTube channel for you to watch later. So go ahead and tell others also, if you think they are missing out on something, they can come back and view the interaction here, right here. Please also subscribe to our channel if you have not, and do spread the word. We are doing these lectures, these interactions every second Saturday, every alternate Saturday, in fact, now, because we have several lectures and the experts are ready to interact with you. So we'll let you know about the next topic and the next speaker very soon. Please stay tuned, and we'll see you back in about 2 weeks' time. So with another thanks to Dr. Surhud More here, we end this session. Thank you all for listening in.